In this week's streaming audio, we're talking about storage. Now, I'm going to kick this off with a clue as to my age. When I was a young teenager, I bought my first memory expansion board at a trade show. Yes, I was the kind of teenager that went to computing trade shows. And it was a circuit board. It was about the size of a piece of toast. And it had a massive 0.5 megabyte of extra memory for my computer. Fast forward to today, and you can tell people that you've just bought a 1 terabyte SSD, and they won't bat an eyelid. I mean, how things change. And yet, even with all that extra storage, we can easily find enough data to fill disks like that up. So the question arises, how does Apache Kafka cope when even the largest disk size isn't enough? And equally, are there reasons to think about how it copes about disk sizes, even when your data isn't that big? The answer is yes, and the hint is recovery times. Joining me to talk about all this is Rittika Adhikari, who works on the Kafka Storage Foundations team here at Confluent. And she's going to take us through tiered storage, what it is, how it works, what difference it will make to you, and why it matters no matter how large or small your data sets are. Before we begin, streaming audio is brought to you by our education site, Confluent Developer, and our cloud service for Apache Kafka, Confluent Cloud. More about those at the end, but for now, I'm your host, Kris Jenkins. This is Streaming Audio. Let's get into it. Joining me today to talk about tiered storage is Rittika Adhikari. Rittika, how are you?
I'm good. How are you?
Very well, thank you. So you are you're with us at Confluent, and you work on our something storage team. Remind me.
I work on the Kafka Storage Foundations team. So we work on building out the tiered storage feature and ensuring that it remains performant even under cloud storage failures, etc.
Oh God, so that sounds like one of those things where under the hood it's a lot more work than I predict.
For sure.
So you can take me through the details of that, but go back to the start. Why is tiered storage worth having?
So there are three motivating factors that we had that actually inspired us to build tiered storage in the first place. They were cost, performance, and manageability. So first of all, we didn't really have any means of infinite retention when we first created tiered storage. Before we created tiered storage, we weren't able to use the same tooling to playback and deposit data. And we would need to use SSDs if we wanted to store data in Kafka forever. So we kind of thought about, well, we ideally want Kafka to be a data lake. So how can we improve costs of actually keeping data in Kafka? And what we came up with was creating one tier for elasticity and throughput for long-term storage, and one tier for high cost and low latency for short-term storage. And we also, prior to tiered storage, noticed that re-replication was super expensive because you might have like 2 weeks of data or so on each of the brokers, and you would need to replace all of that data. And this ends up impacting all the brokers since you're replicating a lot more. So by decoupling storage, we're only replicating the hot set as opposed to like 2 weeks worth of data. So it's a lot smaller amount of data that ends up making the process a lot quicker.
Right. So if I've got this right, you've got topics can get really huge, like properly huge. Like, I know Honeycomb are taking in something like 50 million events a second. So you can
Oh, wow.
easily, if you want to, get into petabytes.
Yeah, you really could.
And you really don't want to buy a petabyte solid state disk. Not
Yeah,
yet.
that would end up being pretty expensive, at least at
Yeah.
current prices.
Give it 10 years, but for now, so the idea is that you split a topic up into the hot set. Is that the term?
Yeah, so we take our data and we kind of, after some point of time, your data is eligible for tiering. Once it's flushed from the page cache into disk, it's eligible for tiering. And then after that point, we would tier that eligible data to the remote object store. So instead of persisting on the disk, it would end up persisting in remote object store.
Something like S3.
Yeah, exactly. S3,
Right.
Azure, or GCP.
Right. Okay. And so you've got that's going to create two problems as I see it. One is that how do you access the old data as transparently as the new data? And the other is how do you manage replication when a node completely dies and has to be brought back up? That's what you're talking about.
Right. So for your first question, how do we still access the data transparently? We like nothing really changes at the user level. So when you're fetching data, you're still able to fetch data from the remote object store through like your consumers. Nothing really changes for the user. Internally, a lot changes, but uh, maybe I'll quickly like walk us through kind of how tiered storage works to kind of give us give a baseline understanding of what's
Yeah,
happening under the hood.
give us the best description of the algorithm you can without diagrams.
So at the core, we're just moving bytes from one tier of storage to another. We can divide this up into tiering any eligible data to a remote store, then retrieving tiered data whenever the user is requesting it, and garbage collecting any data that has reached its retention period or has been deleted. Yeah. So uh, a Kafka partition is comprised of multiple segment files. Data produced to a partition is first written to a page cache, and then periodically it's flushed to the local disk. And we would have to repeat the same process for any replicas that we would have. So once the data is in the disk, like I was saying, it's eligible to be tiered or archived to remote storage and can be deleted from the disk. So the leader of the partition is the guy who's responsible for tiering this data. And we end up deleting any data on the disk based on this hotset. So hotset is this configuration that basically determines how much data we want to keep on the disk, like at a time, like for like quick access. Um, so this is configurable using either like Confluent tier local hotset milliseconds, so that's by time, or by number of bytes, so that's Confluent tier local hotset bytes. And we typically configure this to be the size of the page cache on the broker. So this way, real-time reads near the tail of the consumer will come from the page cache, and otherwise we'll be reading from the remote store. Yeah, and oh yeah,
Just to quantify that, how large does the page cache tend to be?
uh,
Are we
not
talking
sure.
are we talking megabytes, gigabytes, kilobytes? Just give me an order of magnitude.
I would guess
Okay,
maybe
we
like.
sorry, I didn't say there was going to be a numeric quiz in this interview.
No worries.
But something that's able to be fast enough to access for like the leading edge of the topic, right?
Yeah,
Yeah.
exactly.
Okay.
Yeah. Uh, cool.
So
Um,
inside under the hood is the broker keeping track and like a consumer connects and says offset earliest, and the broker says, that offset's over on S3
yes,
or something.
exactly. So we actually have this internal topic called Confluent Tiered State, which acts as our source of truth of which data exists inside remote storage. And our broker uses this to build a view of the log and where our data is actually located. So whenever like we receive a request to consume from a certain offset, the broker determines if we should be fetching locally from the hotset or the untiered part of the log, or if that data actually is present in remote storage. So yeah, so that's how we end up deciding where we should be starting.
And so somewhere on S3 there's literally like a segment file for each segment that would have been on disk, or a combined segment file.
Yeah, so yeah,
Right. With apologies to Google and Azure, I always think in terms of S3 and
I think a
AWS.
lot of people do.
Those are
S3
my
did it first.
biases. Yeah.
That's all it was.
So, and take me through how that affects replication again.
So now we have way less data on the burger's individual disks. So that makes replicating a lot quicker because you only have to replicate the hot set as opposed to replicating like, I don't know, like 2 weeks of data, which could be terabytes, petabytes. So it could take a
Yeah.
lot longer. And with like the data already remaining in remote object stores, you don't really have to change anything at that layer per se. You don't have to replicate that data anywhere else. Um, yeah.
Right. So you're also relying on the fact that something like S3 is replicating that data for you.
Yeah, like so like that we're like storing our data in S3 and that the data is existing over there. So we're relying on that.
Okay. Do you also use that to lean into like multi availability zone type stuff, or is that still handled by something like what's it called, cluster linking?
I think this is still handled by cluster linking, if I remember correctly.
Okay, I'm going to grill you on lots of different things on this because I want to get all the details I can out of you. Um, so, yeah, okay, I'm building up the picture in my head, and so the broker is managing all that, so it's still transparent to the end user.
Mhm.
What kind of performance differences do you see as a reader of old data versus new data?
So for us, it was really important while we were implementing and building out this feature that we made sure that we're not seeing a degradation in performance for sure. So like we should be seeing an improvement. That was kind of like our goal. So we were kind of making sure that Kafka's staying up even if our like cloud storage is like going down, etc. Like we were really considering these things while we were trying to build out the tier storage feature, and we were testing to make sure that we maintain availability, maintain performance. Yeah.
How did you go about that? Because it's like it's a tricky thing to do. Because a lot of these topics that you're testing with are going to be eventually live production topics, right? And you're suddenly splitting them into two views of the world under the hood.
Right. So it was a lot of just improving our testing and adding more formal verification and just kind of like simulations, etc. Just making sure that um, we're like when we're designing and when we're testing, we're thinking about what could go wrong because kind of tier storage was kind of like changing the engine of an airplane while the airplane's still flying. Like we don't want the airplane to go down.
Yeah.
We want to maintain feature parity, make sure we're not losing any data. And we kind of just assumed like what will go wrong will go wrong. So
Yeah.
so that way you got to be really careful.
Because this is the tricky thing when you're a cloud provider, right? You can't just say, here's the new release, you shut down your system and upgrade and bring it back up.
Yeah, exactly.
Yeah, yeah. The plane, as you say, is always moving.
Yeah.
Just to check, when you say formal verification, do you actually mean like algorithmic, uh, like, did you pull out proof assistance and model it that way, or do you mean
Oh
like
no.
like lots of very rigorous testing?
Lots of very rigorous testing,
Right.
lots of system testing, etc.
What was your personal involvement in the tiered storage project? How did you get
uh,
your hands dirty on this?
so the first time I was involved with Confluent slash tiered storage was back in summer of 2020. I was actually an intern.
Ah,
So tiered storage had been fully implemented for S3 at that point, but we were still working on, getting GCP, getting it compatible with GCP and Azure at that point. Um, but like my intern project at least was based off of the fact that not all customers will want to use these cloud providers, and maybe they might actually want to use their own on-prem storage. And a lot of these on-prem object stores actually implement the S3 API because, well, like it's one of the most commonly known object
Really?
stores.
So it's become like an informal standard for object
Yeah,
storage.
a lot of object stores do end up implementing the S3 API. So theoretically, we should also at that point and currently we should be compatible with any of those on-prem stores.
Oh,
So my
right.
project was about building a object store compatibility framework in order to verify any correctness and performance guarantees with these on-prem stores that implement this API. So kind of just making sure that like, okay, like, is it working correctly? Are we, still maintaining all of the guarantees that we're like promising? Like, is this like truly compatible? Is this something that we can verify and say that yes, you can use this on-prem object store. We know that this works.
Oh, right. So you can actually certify someone's on-premises object
Yep,
store as being good enough for the
exactly.
job.
Exactly.
Interesting. God,
Um, yeah,
that's a
so
fun
that was
task.
yeah. So that was the first thing that I worked on when I was at Confluent. And then I joined earlier
Officially, no
earlier
longer an intern
officially
being
joined.
paid properly, I hope.
Yes, yeah. So I joined as not an intern earlier this year. And currently, most of my projects have been around making sure that tiered storage slash Kafka remains performant, even if we're facing any partial or full storage unavailability.
Oh, does that actually come up often? Like S3 is
Yeah,
unavailable?
yeah, it happens.
God.
Definitely happens.
Out of
Yeah, and we
interest.
don't want to see like any like produce or consume latency spikes. Like we don't want to we ideally we don't want to be seeing too many like spikes or too much performance hits from something like that.
And you've got like three cloud providers to monitor for that, right?
Oh yeah.
Out of interest, are the three providers very different in the way they do object storage, apart from APIs?
um, I think there are some cloud providers that we're all a little bit more biased toward. uh, in the sense of like how like things are performing under the hood and how we see how we see things how we see things working. But yeah,
I'm not sure if I should ask you what the good and the bad ones are. That might be too controversial.
yeah, I
No, okay, we're not going there. We're not going there.
yeah.
So how are things evolving? So you say it's in Confluent Cloud. It's available for all the cloud providers, right?
Yes, all the major cloud providers. We've got S3, GCS, Azure. We've got a working for all three of those officially.
So a lot of your work is kind of day to day, making sure it's all operating as normal.
Yeah, so kind of like making sure things are operating like smoothly, make sure we're still like improving performance where we can, improving availability where we can. Yeah, things like that.
Okay. How long did that take to get to, by the way? Do you know, from the inception of the idea that we should do this to it's available generally?
So I know Azure, I believe we like released like I think middle of this year from what I if I remember correctly, like middle or like maybe like March or April, something like that. Um, I might be getting the dates wrong. But and S3 I think was released by the time I was interning. So I know at least for GCS and Azure combined, it took like roughly like 2 years, I would
Yes.
say. So maybe
Yeah.
like another year or so for S3 if I had to guess.
That's the cost of, as you say, replacing the engine while the plane's moving. Right.
Exactly. You got
The
to be really
long,
careful
slow, and
about it.
careful. Yeah. But okay, so with that in place, where is it starting to evolve the design?
So kind of for the future, one cool thing that's gonna be coming into play is tiered compaction, which will allow us to have tiered compacted topics, which we don't currently offer. So we're starting to run that in production and we're getting ready for a broader rollout. So make sure to look out for that. um,
Is there much demand for that? Because I thought the whole point of a a compacted topic is that it's going to take up a lot less space.
right. But then it can like just decoupling the compaction from the brokers also will improve like performance, etc.
Oh, okay. Yeah, okay. I can see how that would come in. So here's another potentially controversial topic, but I have to ask. Tell me about because this is Confluent only right at the moment, and it's in
Right.
Confluent platform. So we have to talk about the open source Kafka version. Which is under KIP 405, I believe.
Yep. Yep, that's
Tell
right.
me everything you know about that, because I know people will ask.
So as for everything I know about that, we've been helping out a bit with like we helped out with like the design review and we've been helping them with uh with like reviews and so as needed. Um I unfortunately don't have any idea on the Kip 4.5 release timeline, but yeah, definitely something to look out for and definitely exciting for the open source community.
But it is It is an independent implementation of the same idea.
Yeah, it's the same idea, like roughly like I guess like design wise, like they are like very similar concepts. Um, but yeah, but then under the hood implementation is like obviously they're they're very different ways of implementing things. Um, but
It,
yeah.
right. Okay. Is that so? That makes me. I have to ask: Is that how much does that mean that the code base of Confluent Kafka and open source Kafka are diverging?
Um, I would say a significant amount. Like I would say like or well, a significant amount for like features like tiered storage. Like I would say the way that even though like I think at a high level the designs like concepts and all are like pretty similar, I think like at a lower level like there are things that we've like done differently, like learnings that we've had like also because we started tiered storage like definitely like three-ish years ago, right?
Yeah.
So we've obviously had like a lot of learnings from that. So in that sense, like there's definitely a divergence. Um, I do think we do try to stay up to date with open source Kafka and make sure like we're taking any improvements um, that are available in open source and vice versa if we notice anything. Um, yeah,
Yeah. I guess we're always going to be like on the same page from a logical level, but when you're a cloud
exactly.
provider, the way you deal with the disk side of things at the physical level, it's got to change and evolve partly, right? Is that fair to say?
Exactly.
Yeah.
Like I think like a lot of like smaller things like end up evolving and then there are some features that are available on Confluent Cloud that aren't available in Apache Kafka. So then that also is obviously different. Yeah.
Okay. So if someone has an existing cluster on Confluent Cloud, is it something that they can enable now? Is it how do they get started with it? Can you change on a per topic basis or is it per cluster or what's the deal?
Yeah, so we actually do have a configuration that allows us to change it on like a broker slash cluster level. So then whenever we enable that, the archiver will start uploading any segments and will, eventually like just continue the way that tier storage work and like purge any local data based on retention, based on hotset retention.
Okay.
Um,
So you just flip a
yeah,
flag and eventually all your topics will be tiered
yes, they will
as long as
start
they're not
tiering.
compacted.
Exactly.
Yeah.
That is for later.
Okay.
For but yeah, there is also a topic level config um, that we can also enable to make certain topics tiered.
That's good. So you can be that fine grained if you really need to be.
Exactly.
But I think you have promised us that the only performance difference will be an improvement. So maybe you don't need to. In fact, I should ask you about that. What has been the impact of rolling this out? to like end users?
Yeah. So for example, banks are one like of our several user cases. Compliance would need you to store your data for like X number of years.
Hmm.
And tiered storage makes it a lot more easy and cost efficient to do so. Um, and then this also goes back into the idea of Kafka being like our data lake. So Kafka remains our source of truth. This is where we created our data. This is where we save our data and access our data. Whereas before we were only able to use Kafka as a source of truth for like our newest data. Um, and it just has made existing use cases much more manageable and feasible. Customers now get the flexibility to economically increase retention and don't need to rebuild their topics from scratch. Yeah, and they don't need to worry about adding any additional compute just to store data. Re-replication is faster. Reading historical data is no longer a limitation, and they just don't need to think about how much data they need to store because it doesn't affect their performance or cost that
Yeah,
much.
it's got to be much cheaper to store large amounts of data off an SSD, right?
Exactly.
Yeah. What about, because I know we use Kafka internally, has it had any effect on us?
Yeah, so prior to tier storage, we had to use magnetic volumes, but with tier storage, we can use like smaller SSDs as well. Um, and
Oh, yeah.
yeah, yeah, so
Because
now
your
we
broker machines can actually be on a smaller AWS EC2 instance, right?
exactly.
Yeah.
Um, yeah, so now we just have a lot more elasticity in how much data we can store and the number of operations needed on the cluster. And like I said, re-replication has become so much nicer than what it apparently used to be. Um,
Because failures do happen, and when they happen, you want recovery to be possible first and quick
yes,
second, right?
exactly.
Yeah. Okay, that sounds like as complete a picture of tiered storage as we can get, unless I can make you promise me a release date for the open source version.
Ah,
You're not going to do that, are you?
that I don't know.
Okay, that's out of your hands. Fair enough.
Out of my hands. And
I shall grill you no more. Rittika, thanks for joining us.
all right, thank you so much, Kris.
Thank you, Rittika. I know some people out there have asked me for a timeline for open source tiered storage. I'm sorry, I did try to get a prediction, but as you heard, it's out of Rittika's hands. I'm looking forward to everybody being able to use it. In the meantime, I am glad that the cloud version that we have available now sounds like a pretty easy migration and operational path. I want to stay in user space as a programmer, and I want that kind of stuff to be transparent, so that was good to hear. If you enjoyed this discussion, if you learned something from it, please consider the like button and the review button and the rating buttons and the sharing buttons and all those things. You and I both know it feeds into algorithms which feed into us being able to make more interesting episodes of this podcast. So please take a moment. It also makes me feel really good, which is nice. Before we go, streaming audio is brought to you by Confluent Developer, which is our tech site that teaches you everything you need to know about Apache Kafka and building real-time event-based systems in general. We've got tutorials, guides to connectors, architectural guides. We've got complete build walkthroughs, and we've got the back catalogue for this podcast. So take a look at developer.confluent.io. And if you want to get your own Kafka cluster up and running with tiered storage enabled today, go and look at our cloud service, confluent.cloud. You can sign up and have Kafka running reliably in minutes. And if you use the code podcast100 on your account, you'll get some extra free credit to run with. With that, it remains for me to thank Rittika Adhikari for joining us and you for listening. I've been your host, Kris Jenkins, and I will catch you next time.